So hello friends, I am Vakasia. Currently I am studying in ICT branch in Marwadi University. Our project is number conversation, which is guided by our faculty Professor Kumar Singh and our HOD C.D. Verma. So friends, this is our code. We have 9 class, 1 main class and 8 method classes. So our main class is extends FX class, and it extends fraction octal class and fraction binary class, then hexadecimal to decimal converter, octal to decimal, binary to decimal, and decimal to any. And our main parent class is decimal to any, because in any method first we have to convert any base to decimal, and then we can convert in binary, octal, hex with decimal. So first we will go to the decimal to any converter. Here 3 methods. First is a decimal to binary. Here we declared long because we don't know user want to how many lengths in the long, because we don't know what is length of the variable which is entered by user. If user entered data with high length and we store in an integer, so that not possible to convert in binary, so we use here long. And then methods which converts decimal to binary, which we can also see on YouTube. We also learned about in lectures. So here we get value, the converted value in string, and we declared here array to store answers. Here array of 3. First array is from binary, second array is for octal, and third is for hexadecimal. So here we use a string builder. When continuously A is adding one by one when while loop is running, and string builder append the string which is coming from while, and it's stored in H0. It is our binary value. Similarly in octal, here we also use long. In binary we modulus 2 because the base of binary is 2, and here we use 8 because base of octal is 8. And same method, but variables are changed to store particular answers. In hexadecimal, bit a little. Some portion is changed because in hexadecimal we have to use A, B, C, D, E, F is a base of 16. So here we use while loop to check the data entered by user, and characters are A, B, C, D, F of them over numeric. So here we use while loop and if else conditions. If any of data, if any of character at a index, particular index is 10, 11, 12, 13, 14 or 15, we have to put there A, B, C, D, E or F. So here we put if if else condition to check the data if data is between 10 to 15, and it is not true, then S6 is equal to S6 plus string value of C. Means the same method which A modulo 16 is added to S6, and after that when A divided by 16 is 0, we have one condition to add, but in value we can't. So here we put add one if else nested if conditions to check, and then we use string builder to store data in string and wire string to the text field. So here AJ2 is string, it is our hexadecimal value. So further we go to binary to decimal class. In the class we use three method also: binary to decimal, then decimal to octal. Means all answers are same. Either you convert binary to decimal, either you convert binary to octal directly, either you convert binary to decimal and then decimal to octal. It is optional. But now binary to decimal, same method. Here we use math.power. Means it is a Java math function for whom we can find exponential answers, and then here we put one condition. In the method of binary to octal, we use same method which is used in decimal to octal. Here we get answer binary to decimal, and this decimal value we can use in convert to octal. So A is equal to lamp 1, and same method as base 8, which is stored in string value, string builder V. Here we use reverse because when value divided by 8 and modulus 8, it is reversed all values. So we have to use reverse function in builder. In JJ1, we stored octal value of binary. In JJ0, we stored decimal value of binary. In hexadecimal, we use same method which is used in decimal. In JJ2, we use the hexadecimal value of binary. Now, in octal to decimal, we use 8 base, 8 power of I, it means 8 power of 0, 1, 2, further. And this is without fraction methods, and in OJ0 we stored decimal value of octal. Similar in binary, when we get decimal value of octal, we can use convert to binary data by decimal values. So it is same method as first class. In hexadecimal, we also use the decimal to hexadecimal method, which is stored in Z2. I will tell you what is the use of these arrays, because we need to store in a text field, we need to print in text field, so these arrays are important to store answers in arrays. So now in hexadecimal, in the class, first we have to check data entered by user is numerical or alphabetic or mixing. So we check a particular character from 0 to length. If A, B, C, D, E or F, and we have to put 10, 11, 12, 13, 14 or 15 as per rules. We use method.power function. This value is final value B, and which is stored in H0 as a string. Therefore, this string which is collected by text field, I will show you later. Now, hexadecimal to binary. In this method, we use decimal to binary because we get here decimal value. So it is easy to get method from here and put here. So we can easily get the answer of hexadecimal to binary, and which is stored in H1, second value, and last hexadecimal to octal. This is also available in decimal to any converter. We can copy here and put here, so which is stored in HEA2. So now, in the main class, check frame. Our A1 is main frame. In this frame, we have to choose the options to convert with fraction or without fraction. In A method, there are actions to performed by without fractions. So I will show you. Our A1 frame is welcome page. So in this welcome page, there are two buttons, without fraction and with fraction, and we can push them and go to the further progress. In A, it is our without fraction frame, number conversion. It is without fraction frame. It is without fraction, and in this frame we have 5 levels. One is decimal value, one is for binary value, one is for octal value, one is for hexadecimal value, one is for error. If user entered wrong data is binary. If user enter the data like 10A, it is error. So we use error. In text field, there are 5 text fields. One is for decimal value, one is for print binary value, one is for print octal value, one is for print hexadecimal value, one is for print errors. What are errors? Here set bounds are set positions with our label exactly where, and this is width and height of labels. In frame, set layout null, because if we want to put labels text field as per our choice, we have to set layout null, and set default call operation is used to close the frame. Buttons, there are 4 buttons: convert from decimal, convert from binary, convert from octal, convert from hex, and back button. And this is our adding. If we made buttons and let them go, then frame can't show us where are our buttons, labels and text fields. So we add the buttons, labels and text fields. In the frame, the number conversion with fraction, there is same positions and same buttons. But so here B6 in the first frame, if B6 button is pressed, then frame will be moved to second frame A, and this is without fraction frame. And if we press the but B7, it will move to A2 frame. It is with fraction frame. In the first frame, if B1 is pressed, then we get the text from text field, and it is set the value in temp, and in temp you can see here temp is used to convert decimal value to binary, octal and hexadecimal, which is stored in HS0, 1, 2. So if B1 is pressed, BA get text from the first text field with stored data in temp. Then we will check if data is numeric, because in decimal only numeric data will be converted to binary, octal and hexadecimal. So here we use try and catch method to check if data is numeric or not. After that, we call the methods to convert number and print out the answers which are stored in H0, 1 and 2. Similarly in B2 and B3 and B4. These fractions. Now we will move to with fractions methods. First method, fraction decimal to binary. In this method we will use strings. First we use strings. We catch data FB and Z, and with this method first we have to check where is dot exactly at which index. So we stored index in X, then we divide before dot and after dot. Before dot we have to convert in decimal, and after dot we have to convert in into 2. This we double dot press double convert double from the string, and this will store FB1 fraction value of binary from the decimal. Similarly, octal value, but in octal we have base 8, so we multiply by 8 into D. In hexadecimal, first we have to check if the enter data is from A, B, C, D, E or F, then we have to put particular value from the 10, if 11, then B, 12, then C, 13, then D, 14, then E, and 15, then F. After that we have one condition which is not applied in a while condition, so we apply here, which is stored after progress FB3 is a hexadecimal. Similarly in binary, first convert binary into decimal. This is code. Then you can easily take this code decimal to octal, put here. It is same if we can convert binary to octal directly, or we can binary to decimal, then decimal to octal. The answers are same. Then hexadecimal. You can also take the code from decimal to hexadecimal. Similarly in octal. So these are 4 methods to the fractions. In main class, there are 4 buttons to print the answers. If C1 is pressed, then G1 get text, then methods are called to decimal and set text to the 2, 3 and 4. This is back buttons. So now I will run the code. So the outputs is the inputs. We are executing building code. So here you can ask us if we want without fraction, then go another family open. So here we put decimal value 10, for example. We push the button, then binaries are 10, 10, octal is 12, hexadecimal is 8. For example, here we put D, F, G, and legal value from binary. So here we can see enter right format for binary value. We also see errors. We will be back with fraction octal value 25.63. Convert and it will show us all 3 value hexadecimal, binary and decimal. This is our code successfully running. So friends, thank you. You hear me. I hope it will be helpful to you. Thank you very much.